Hello everyone. So in today's lecture we're going to go back a little bit and finish our history lesson. We're going to start off with looking at how the standards were developed and how we use the standards, how do we interpret the standards, and how do we make sure that we meet the depth and breadth of the standards. So it's kind of difficult to believe now, but for the majority of the 20th century, there were no standards guiding curriculum and instruction. The majority of the time, the districts would select texts that they felt were appropriate for use in their schools, and the teachers would be left to implement those texts or to perhaps select things that they also considered to be appropriate for their students to use. States started developing standards for English language arts and also for mathematics as early as the 1990s. Remember that each state is tasked for making educational decisions for their state. Therefore, creating the state standards is the responsibility and task for each one of the states. The federal government has no authority to put anything in place for them or to force them to adhere to any federal regulations in terms of adoption of standards. However, they can put pressure on them by not providing money, taking away state-funded programs if the states do not comply with regulations or conditions that the federal government puts into place. When the state standards started working on this individually, all 50 states started working on this individually, there was a lot of variation from state standards to state standards from one state to another. They would vary from very little to a considerable change. Sometimes a lot of thought and effort would go into creating the standards by that state, and sometimes states would just adopt another state's standards. It just depended on how much money they had, how much they were interested in doing so, what the political climate was. So this was happening slowly, right? Everybody's slowly starting to develop their state standards. The first time something comprehensive came out for mathematics was in the year 2000 by the NCTM. This is a few years after I started teaching myself, and so I actually remember when these things started to roll out. The initial introduction for math standards actually came from the NCTM, and they were actually looking at sort of like the big idea of what was necessary for students to learn and understand and the reasons for that. And they were really working off of the Adding It Up book that had come out and trying to develop that into sort of a more concrete curriculum. Again, as a reminder, the NCTM is not a governing body. So while they might conduct research or they might be more of a think tank organization, none of this really was being implemented at all. But it was catching the eye of politicians and policymakers. The initial document that started to flesh all this out was called the Principles and Standards for School Mathematics. And like I said, it came out approximately the year 2000. What it did is it broke the grades into these bands. And so there was like one band for pre-K to 2. There was another band or kind of like section that would talk about the mathematics. It would make sense to go into grades 3rd through 5th grade. And then another band that would address the needs of sort of the typical junior high or middle school instruction. So that would be 6th to 8th grade. And then the high school information or the high school skills would go into the 9th through 12th grade bands. Each one of these bands had content standards. So regardless of which one of these bands you were dealing with or you were working with, you would always have 5 content standards within them. So there was like the number and operations content standards, there was the algebra, there was the geometry, measurement, and then data analysis and probability. And all of those existed in each one of these. So pre-K had all these things, 3rd through 5th grade had all these things, 6th to 8th grade had all these things, and high school had all these things. There was a little bit incorporated into each one of the bands. And that was kind of the first time that they actually started sort of organizing and deciding what made sense to go into which category. In addition to taking the content and putting it into these categories, these 4 distinct bands, the NCTM also looked at other components of mathematics that weren't associated with a particular skill or particular content or operation. And these were called the process standards. They were things like the ability to problem solve, the ability to justify your reasoning, the ability to communicate using subject area vocabulary, connections from some of the skills or content to other types of skills or content, and also being able to represent this information in various ways. So by the year 2000, the federal government was trying to put pressure on the states for everybody to develop standards nationwide. And for mathematics, it was expected that they use the NCTM information to model their state standards. The state standards that were developed started to sort of resemble more of a checklist than anything else. So they would just be like sentences where students had to learn these things, and there were just literally hundreds of them. They were also expected to have some level of process standards. Now, what furthered the implementation of standards was the No Child Left Behind in 2001 during the Bush administration. And the idea of No Child Left Behind was to address certain problems that we've already discussed. First, they wanted to make sure that the teachers that were going into the classrooms, whether elementary, middle school, or high school level, actually were trained and were what they considered to be highly qualified, in quotes, highly qualified to be able to go into the classrooms and instruct children. They wanted to basically get rid of as many emergency credentials as they possibly could. So they wanted to meet the standards for teaching. They also wanted for all students to develop proficiency by 2014. So by 6 years ago, students were supposed to be proficient. In order to hold the schools accountable, they were also looking to increase achievement based on annual, yearly progress points. So each school would be looked at to see if they had actually met their goals for that particular year. If they did meet their goals, then they would be eligible for federal subsidies. If they did not, then they would lose federal money. And also the states were expected to refine the standards on a regular basis. While this seemed to address a lot of the issues that we've already discussed, what it also did is it put a lot of those low socioeconomic schools and the children that attended those schools at a further disadvantage, because a lot of the teachers that were going in to teach and had started on an emergency credential were at a lot of the low socioeconomic schools. The students that were already behind, and so they had a lot more to do in order to obtain proficiency, were already at these low socioeconomic schools. These schools were not the ones that would meet their AYP goals, and so they would be punished by losing some of the federal money. So this became sort of this continuous cycle of almost like a punishment against certain schools versus others. I don't mean to at all take the side of one administration over the other. What my goal is here is to really point out that while there has been instances that the government has tried to address problems in education, many times more problems have been created, and they have targeted some groups over others. So this is 2001. This is during the Bush administration. In 2010, a group of mathematicians and math teachers came together to look at what are the critical areas of where students need to learn mathematics in order to be viable candidates for the jobs of the future, and then also reimagining the way that the standards had been written in the past. A lot of this work came out of the University of Arizona. It had like a think tank beginning. Many times, those are the things that catch the eye of politicians and policymakers. And in 2010, that's when it caught the Obama administration's eye of what would it look like to have Common Core state standards. Using the Common Core state standards, that would address the variation in state standards when we're looking at comparing what students are learning in, say, a state like California to what they're learning in a state like Michigan, to what they're learning in a state like Illinois, or New York, or Florida, or Texas, or Alaska. In the Obama administration, President Obama decided to go ahead and adopt the Common Core state standards and begin to address the need for students to come out of high school proficient and either college or career ready. So at this time, I'm going to have you watch a clip by the creators of the Common Core state standards. I feel that they're able to explain this much more eloquently than I could ever do so. Well, since they worked on it themselves, they're able to give you a very clear understanding of what their goals were and how they meant to achieve those goals. So what I want you to do now is go ahead and pause this video and go ahead and go to the next clips. Again, there are various ways that you can do this. You can go into the Google Slides and there will be a link into the Google Slides. If you're watching this from YouTube, you can go in the description box below and it will have a link to all the videos. And then also you can go directly from the weekly module in Blackboard and click on the next link to watch it embedded into Blackboard. Professors McCullough and Zimba stated that the purpose of the Common Core state standards is to really look at what standards had been developed thus far for various states and really try to come up with the best of what was out there. The goal was to eliminate the need for remediation, which was then 10 years ago and continues to be a huge obstacle as students progress into higher education. And then also to attempt to make them more career ready so that if a student decided to go directly into a career following high school, they would have the skills in order to do that. It looked at deeper mastery of the fundamentals, but the fundamentals did not necessarily mean arithmetic. It was the fundamentals of each domain. That they would look at fewer standards and the concentration of these standards would exist for a certain period of time and then end. As we prepare more teachers to address the needs of the Common Core standard, is that there were 3 shifts. One was focus, so really deciding which one of the standards for each grade should be the focus for that grade. Coherence, to think across grades and link major topics within and across the grades. So looking at what had been discussed earlier in preparing teachers for education and their mathematical knowledge and looking at the curricular knowledge, so having a very clear understanding of how these concepts move from one grade to another. And then also the focus on rigor. So pursuing conceptual understanding, of course, making sure that students had procedural skill and fluency, and then application. So in rigor, they are continuing to address what was discussed in the Adding It Up book, right? That they said that they wanted conceptual understanding, procedural fluency, and then application could be also considered to be the process or the strategies or the real-world applications that Adding It Up also considered. As we move through this, I want you to keep one thing in mind, that the Common Core state standards are standards. They are not curriculum. And the difference between the two is that standards is one of the components of curriculum. Curriculum involves all the resources that you need, all the pedagogy that you would need, all the homeworks, activities. Curriculum would also include things like assessments, extensions. All those things are curriculum. All of those things build curriculum in addition to the standards. So the standards are just a small portion of the curriculum. And always the standards is what guides the curriculum. It's never the text. It's never what the teacher wants to guide the curriculum. It's the standards. The standards are the cornerstone to all curriculum in mathematics. So when the Common Core State Standards writing team began to develop the standards themselves, one of the things that they did was they looked at the standards at least 2/3 of the countries in the world that were considered to be what they call A+ countries. These were countries where students were excelling in mathematics. And here you can see on this side of the diagram, you have that in first grade there were like 3 standards. In second grade there were 3 standards. In third grade it jumped up to, I think that's 7 standards. You saw a lot of it in fourth and fifth grade, and then it just kind of, it continued to be quite a bit. I'll see if I can put the original document in the description box below, but these were actually aligned. Each one of these rows were actually aligned with a particular skill. If you compared how other countries determined what standards should be for the various grades and how the United States did, you can see that even in first grade that there were a lot more standards for students to have to learn in second grade. And what would ultimately happen is that students would not be able to achieve all these standards, right? The teacher would run out of time, we would not be able to address them, or the students needed more time than was available for them to actually comprehend what was happening, or it could be that the teacher just didn't have the ability or didn't have the resources to be able to give them the kind of experience that they needed to fully understand the concepts behind the mathematics before they had to go to the next grade, right? And so this would just sort of pile up. So at the end of 8th grade, there would be a lot of gaps in through here. So what the Common Core State Standards did, and we already discussed a little bit in the focus, is they really tried to narrow it down to what were the most important concepts. And looking at those concepts is how they created the domains. And these are kind of the ideas of the domain. So here from kindergarten to 5th grade, students would concentrate on operations and algebraic thinking. They would work on base 10 from kindergarten all the way up to 5th grade. And starting at kindergarten, number and operations for base 10 started at things like counting. And then when they got to 5th grade, operations in base 10 were including decimals and percents. Fractions would start at about 3rd grade and continue on to about 5th grade. At that time, all these 3 domains would stop, and this information and the concepts that had been acquired during this time would be transferred into 2 domains that were expressions and equations, and then the number system. So extending base 10 to also include numbers to start to look at negative numbers, to start to look at irrational numbers, looking at ways to extend operations into expressions and equations, and then finally in high school they would be able to sort of take all these big ideas that they've been able to experience and turn them into this, what McCullough calls a rich experience with algebra. And that's what would happen in high school. The high school standards are very different. They're a completely different animal. So here we can see again how the focus goes from one grade to the other, how the focus areas are arranged. So when reading the Common Core State Standards, and we're going to go ahead and pop open the document here in a minute, they're pretty easy to read in the way that they've decided to sort of like arrange them. When you open up the document, you'll see that the grades will have this gray bar right here, and that gray bar is the domain. So this is 3rd grade, and then NBT stands for number and operations base 10. So number in base 10. The standard itself is this in black bold letters. And then sometimes it will also have a cluster of standards that go under that sort of main standard. Okay, so as we crack open the document in a second, just keep that in mind. This is giving you the domains that we saw here, right? This is the domain for number and operations base 10. They continue from kindergarten all the way to 5th grade. The standard is here in bold. Sometimes the standard has a cluster and sometimes it does not. Sometimes they might even have even more bulleted items, like you'll have 1A, 1B, 1C, but everything that falls underneath the standard is part of the cluster. So what I'd like you to do now is in the description box below or in the materials area of Blackboard, you will find a link for the Common Core State Standards. And when we open it, you will see that it's divided up into different grades. And let me go ahead and open that for you now. So here are the state standards. They're all together in this PDF. You will be able to access it from the description box below. And as you start to sort of unpack this, you'll see that here on page 5, it tells you how they've been organized, that it has the domain, it has the standard, and then the cluster is a group of related standards. We're going to hold off on pages 6, 7, 8 because I want us to discuss the math practices separately. And then you'll start to see that they start to break down into the different grades. And there's this page that seems to be like an introductory page, and then it goes into almost like a table of contents, and then it goes into the standards themselves. This page that is often just seen as an introductory page is probably the most important page as a teacher that you need to read for each one of your grades. This page, I'm going to make this a little bit larger. This page gives you the focus, the critical areas that students need to know in greatest detail so that they will be successful moving forward in this domain. So if you notice right here, it focuses on 2 critical areas, and it will list them for you, and then it goes into detail. Having a very, very, very clear understanding of what your focus standards are for your grade is the key to being successful in meeting your students' needs and preparing them so that they can continue to have a successful math experience as they move forward in this domain. This will not include all of the standards that are listed in subsequent pages. These are the key standards, the focus standards that require the most attention. It does not mean that you don't address those other standards. It means that as you're starting to unpack these standards and looking at what are the most relevant and important standards for your students, that you keep in mind whatever is listed on these pages, on the focus standard pages. So we're going to look at a kindergarten example. One of the reasons why I picked kindergarten is because it was first in the progressions, but also I wanted to sort of keep away from anything that might be considered to be a little bit more complex and kind of start at the beginning, assuming that the students have not had a whole lot of experience with mathematics as they approached kindergarten, and looking at something that's considered to be super, super simple, just addition with single digits, and looking at how that simple idea can be a little bit more complex than you ever anticipated. So here is the focus standard, and I apologize for reading this to you aloud. If you want to pause and read it for yourself and then fast forward, that's totally understandable. But I just want to kind of put things into context for myself as I film. So this is the mathematics focus standards, and I'm just going to focus on the first one. It says, in kindergarten, instructional time should focus on 2 critical areas. And like I said, we're just going to focus on the first one. Representing, relating, and operating on whole numbers, initially with sets of objects. Okay, so let's think about that for just a second. They're starting with the representation of quantities.
relating them likely to one another. Okay, that part where it says relating, not really too clear on what it means at this point, and operating with whole numbers, and saying initially with sets of objects. So it's bringing in the concrete stage of CRA. Now I'm going to read the first section in more detail. Students should use numbers, including written numerals, okay, so taking it to the abstract, to represent quantities and to solve quantitative problems, such as counting objects in a set, counting out a given number of objects, comparing sets or numerals, and modeling simple joining and separating situation with sets of objects. Okay, so this is all really relying heavily on the concrete phase of the CRA techniques, right? It doesn't mention representation. That does not mean that you skip it to go straight to abstract. Even though the representation stage is not mentioned here, it's still 100% important. You should always go from concrete to representational to abstract, and it's eventually going to solve equations such as 5 plus 2 equals 7 and 7 minus 2 equals 5. Now we're just going to concentrate on addition in the upcoming example, but I'm going to go ahead and just read this whole thing. Should see addition and subtraction equations, and student writing of equations in kindergarten is encouraged but not required. So at this point, they should be able to see the abstract phase and derive meaning from it, but they don't necessarily need to write it themselves. And what I think it's interesting is any of you are working with language acquisition techniques. When we acquire any language, we first learn how to listen to it, we learn how to speak it, then usually we learn how to read it, and then finally the last is writing. So with a lot of conversation, having students listen to you, making them speak, and then allowing them to read with mathematics, we're going through a natural and accepted language acquisition steps. Students choose, combine, and apply effective strategies for answering quantitative questions. So here they are being exposed to strategies. After they've been exposed, they should be able to choose which one they would prefer to use or which one seems most efficient according to their own minds, and also seeing how they can, if they choose, combine different strategies, including quickly recognizing the cardinalities of small sets of numbers, counting and producing sets of given sizes, counting the number of objects in combined sets, and counting the number of objects that remain in the set after some are taken away. The very last sentence of the sort of like burgundy paragraph at the top says, more learning time in kindergarten should be devoted to number than to other topics. Now, again, like I mentioned before, this does not mean that you ignore those other topics. It's saying that students need to come away from kindergarten with number sense, and they also describe shapes and space. That is the prime focus for kindergarten. So let's go here to where we talk about operations and algebraic thinking. We're going to actually focus on K.OA and look at some of these standards and sort of start to unpack them. So we're going from a very broad description of what should be done in kindergarten to a little bit more detail. Understand addition as putting together and adding to, and understanding subtraction as taken apart. We're going to focus on addition here. Represent addition and subtraction with objects, fingers, mental images, drawings. Okay, so here we have the representation phase. Drawings should not show details, but should show the mathematics in the problem. Again, understanding that you're going to have to show children how to draw these things. You're going to have to show them how to use movement and arrows and things like that to show what's happening in their drawings. Sounds like claps, acting out situations, verbal explanations, expressions, and equations. So really here we're talking about all these ideas that came out of Vygotsky. So the speech and bringing the speech out and involving the critiquing and the listening to other people's explanations, being able to add to conversations, solve addition and subtraction word problems, and then add and subtract within 10. Like for example, by using objects or drawings to represent the problem. Okay, here their focus is within 10, so students should be able to use all the counting numbers within 10. Does it say anything about 0? Decompose numbers less than or equal to 10 into pairs or more than one way. For example, using objects or drawings, and record each decomposition by drawing or equation. So taking a whole number and being able to break it up into smaller parts of it. So taking 5 and being able to break it up into, for any number from 1 to 9, so it's not including 0, find the number that makes 10 when added to a given number. So it wants all the whole number sums of 10 by using objects or drawings, and record the answer with a drawing or equation. Again, what I really love about this is although they didn't talk about the representation stage earlier, they're now bringing it in. So this representation stage is really crucial because it's that bridge between the concrete when they're using manipulatives and the abstract when they're able to use an equation. So here, the creators of the Common Core are saying, well, some students may need a little bit more time to get to the equation. Allow them to draw until they see the equation as almost like a shortcut or just a language to describe this information. And then finally, they should have built fluency when adding and subtracting within 5. Notice, this does not bring up the number 0. So again, here is the domain, here is the standard, and these are the clusters.
So now that we've had a chance to look at the focus standard, right, this page right here, the focus standards right here, and we've had a chance to start to unpack this domain right here, the one on operations and algebraic thinking for kindergarten, the next step is to go into the progressions. Now, the great thing about the progressions is that it starts to build your own curriculum knowledge as a teacher, which, if we go back to Schulman's work, it's the idea that good math teachers need content knowledge, they need pedagogical knowledge, and they also need curriculum knowledge, which is the awareness of how topics are arranged laterally and vertically throughout the curriculum. In order to do this, you're going to go into the progressions. Now, the progressions, there's a lot of different ways to use them. I have put a PDF version of all the progressions in the description box and in the course materials folder in Blackboard, where you can have easy access to them. So first, let's just look at the PDF of the progressions, and then I'm going to show you how we can use technology to sort of cut down on the work. So here are the progressions. I've organized them in a folder for you. We're going to keep working with kindergarten standards that we were just looking at. And this one, you'll see it right here. It'll be CCOA. So this is counting and cardinality, operations and algebra, kindergarten to 5th grade. And that's how you read this little code. So I'm going to go ahead and click that now. And I open it. And it's going to start explaining the ideas behind how this was set up. And if you notice, on the left side, it will give you information about how students learn, how it's important, how it ties into subsequent grades, and off on the right, it matches these ideas with the standards. So that's what I really like about this, is it'll match it up side by side. It will also give you information about what is considered to be part of that standard. So let's look at this top one right now. Remember, the old standard said that students would just be using objects and drawings and eventually going into the abstract phase of using symbols to explain what's happening within mathematics. But, it just said adding. It didn't go into really a lot of detail, and you may think, well, it's just adding. But there's different ways adding can be represented. One way that adding can be represented, which is, I believe, to be the most common way that you think of addition, is that you have two addends, one number plus another number in the most basic level, and you're trying to find the total.
And this is called a result unknown type of question. The other one is that there is some beginning quantity, and to that quantity you added an unknown quantity, and you know what the final outcome is. So you've got A plus something equals C. This is called a change unknown, and change unknown is also part of the addition standard. The final type of addition problem is when the start is unknown. So there's some unknown quantity that the students are starting with, and to that you're going to add some amount, and you're going to get a resultant amount. You're going to get the sum. So all of these examples are part of the addition, and making sure that we are working with each one of these, that students are being assessed for each one of these, that students are having opportunity to work in the concrete with each one of these types of questions, and moving to the representation stage for each type of question, and being able to engage in social dialogue with their peers, and time to reflect, and time to accommodate, and time to assimilate. All of those components have to come together for the standard of addition to be met, for result unknown, for change unknown, and for start unknown. While this may seem very simple, and it is because it's just single digit addition, right? For us it's very obvious. For a little child it's not very obvious. These seem like completely different concepts, especially when they haven't worked with the idea of nothingness, zero. Taking time to look at this is really important. Going to the progressions back and forth can be a drag. So what I want to share with you is this really great website called Achieve the Core. And this is a free website. You can go in, make yourself a free account. When you go into Achieve the Core, you'll have just a ton of free resources. One of my favorite ones is this coherence map. That's at the very bottom where you have mathematics classroom resources, and it's the very last link. And when you click on the coherence map, what it does is you can actually go in and just hit get started, and you decide which grade you want. So we want kindergarten. It gives you all the domains for kindergarten. We've been working with KOA, so we're going to click on that one. And we have actually been working with KOA A1. So we've been working with the very first standard and substandard A. Represent addition and subtraction with objects, fingers, mental images, drawings, sounds, acting out situations, verbal explanations, expressions, and equations. Okay, it gives you example tasks. But what's really nice is it gives you the progressions, and it gives you a very easy way to download the progressions at will. So it's all in one place. You don't have to worry about, we've been working with that one. Another one that we were working with in the domain KOA is addition word problems. The progressions, they go in and they give you this really great grid that reminds you of what needs to be included to meet the depth and the rigor of that standard. So I think it's an outstanding resource. So what do? First thing you do is you look at the focus standard, see what's important for your grade. Next, you start to unpack those standards, read through them, and then go straight to the progressions and start looking at examples of what you want to do, how you want to meet these things. Like I said, they give you really great tasks that you can go in and use as some ideas on how to meet the standards. They have tons of resources here for you. It's absolutely outstanding resource. As a summary, when you are familiarizing yourselves with the standards for your particular grade level, it's a multi-step process. It starts by having a clear understanding of what your focus standards are.
going in and reading the individual standards so you can identify which ones are part of the focus standards, and then opening up the progressions so that you start to familiarize yourself with the depth and breadth of the standard within the grade, but also understand the connections that come before and after for that same type of domain or skill or topic, whatever it is. A lot of the times, schools will actually have curriculum developers that will unpack the standards for you and develop curriculum mapping for you. That's wonderful. That takes a lot of the guesswork out of it. A lot of the times the books are very easily turnkeyed, or they appear to be very easily turnkeyed into good lessons. That's wonderful. But you as a teacher still have an obligation to make sure that you know they meet the depth and breadth of the standard. There is no one document, there is no one textbook that is going to cover things precisely or that is going to be aligned with your particular needs of your students. So please always go through and do the due diligence of checking to see to what extent and in what ways your resources meet the intentions of the standards. So let's go back to something else we talked about last week. I don't know if you remember this. This was a statement by the NCTM, and it said, "In this changing world, those who understand and can do mathematics will have significantly enhanced opportunities and options for shaping their futures. Mathematical competence opens doors to productive futures. A lack of mathematical competence keeps those doors closed." When we talked about understanding, we decided to operationalize understanding as that it can be defined as a measure of the quality and quantity to the connections that idea has with existing ideas, that understanding is not all or nothing, and that understanding is dependent on existing ideas. And we talked about how we want students to have relational understanding. Relational understanding makes you more of an expert. You're using what you already know and you're expanding your knowledge on that particular subject. Instead of just having random facts floating around in your mind that you're not sure how they connect to anything, and that would be something like on the far extreme, you just have this random fact and you're not sure exactly how it connects. So this might be a really good activity for you to do as you're starting to unpack the standards. What I'd like you to do is to go ahead and go into your standard for a grade that you're interested in working with and count up every time you see the word understanding in that document. If you were to do so, you would find the word understand a lot. In kindergarten, you would find it 8 times, for example. For first grade, 9 times. For second grade, 11 times. For third grade, 20 times. For fourth grade, 23 times. For fifth grade, 24 times. And then for sixth grade, it drops down to 14. So they use this word understand a lot. And because understand is such a vague construct, it's not really a measurable verb. We have to find a way to be able to measure that understanding. And one of the ways that you can use to measure that understanding and looking for relational understanding is using the mathematical practices. The mathematical practices are standards that describe a variety of expertise that mathematics educators at all levels should seek to develop in their students. They rest on the work that was done in the Adding It Up document, where they were looking for adaptive reasoning, strategic competence, conceptual understanding, and procedural fluency. So they were all based on these same ideas. If your students are able to demonstrate the math practices for all the standards, then that is evidence that they have relational understanding. They're able to see the math in a variety of different ways, being able to describe what's happening, being able to explain, etc. The mathematical practices are not standalone. They have to be woven into the curriculum. So they have to be explicitly taught, and they have to be taught in tandem with skills. Just like the POLIA strategies, they have to be explicitly taught, and they work in tandem with skills. And they are much more complex than they appear. So these are the mathematical practices. I'm going to go ahead and have you pause the video here and go ahead and look at the video that I'm going to link to this. As always, if you have the Google Slides open, you can click on the link to go to the video directly. If you're watching this on YouTube, you can find the link in the description box below. And if you're watching this from Blackboard, you can go to the module menu and click on the next clip. You should resume this video after you've finished watching that clip. So we're going to do a little practice at looking at some student work and delving into the standards, the progressions, the mathematical practices, and trying to evaluate what evidence is there that the student met or did not meet the depth and breadth of the standard. Again, you're going to find the domain, cluster, and standard you feel this task is addressing. Use the mathematical practices to analyze the student's understanding of the standard. So you're going to go in, crack open the Common Core State Standards, crack open the progressions, look at the student work, and then use the mathematical practices to find evidence of how well the student understands this standard based on this task. There's going to be 2 slides for you to look at. Hint, this is a 5th grade standard. The question is, Mrs. Wilson has 64 brownies on a plate. 1/2 of her students eat 1 brownie. 1/4 of the students keep 1 brownie for a snack. 1/8 of the students keep 1 brownie to eat at lunch. 8 students keep 1 brownie to take home to eat. Are there any brownies left on Mrs. Wilson's plate? Show all your mathematical thinking. So there are 2 pieces of student work for you to evaluate. There is this first one, and this is the second one. I will create another video or document analyzing this work and link it in the description box below. This is not something that is due for the course. More than anything else, I just want you to go in and start getting your hands dirty with the documents and looking at the mathematical practices. Have a great rest of your day. I'm very sorry that this video was so long. Trust me, it took a lot longer to film it than it did for you to watch it. I will continue to do my best and make sure that I'm trying to get as much information out to you as possible. You have a great rest of your day. Bye!